preset to cut. This is our catalyst. I'm going to make foam here. All right, now this is our foam. Spray this on any fire. It should take it down. Now this is what they asked me to do, so this is what we want to try to do. I would say that's a good enough test for anybody. But to show that that'll hold up in an airplane crash, stick to you, and be a good solution to this biodegradable, non-toxic, recyclable. Give me a spoon, we're going to eat it right here. So now this is a biodegradable, non-toxic, edible product. There it is. All I'm going to get out of it is a little burping, probably. So little kids, they don't die of this in animals, and you have the SPCA down on your air people and all the other people.
Why is it so important for this product to be biodegradable and edible? Because
the air quality and water management, the CDC hazmat, and all the people that make products like this are under extreme duress because of the materials that they use. They pollute the waterways, and we recycle the water. So we can't have toxic materials put on our house and in our environment that is recycled back into the waterways and gets back into the food chain or the water chain, because guess what? We have to eat it and drink it. So now the business program it would be logical to assume that if you're going to make a really non-toxic material, then you should sit there and you should eat your own material to prove that the material is safe. Now I've been eating this stuff, you know, off and on for 5 years. I'm perfectly healthy. I'm a healthy man. But you know what? I don't think you ate melamine or halogenates or fluorocarbons, or if you ate BC or fire retardants or things with phosphates in it, you'd live very long, or anything with any bromines or anything like that. This stuff is completely safe, but I tell you what, in an airplane crash, I just burned 7,000 degrees directly into my hand at a 45-degree angle. There ain't nothing right. Isn't that right, George? You see anything there?
Nope.
I felt no heat. Now, if you take the same foam and you freeze it, you don't get cold transition through it either. So it alleviates cold and it alleviates hot. It won't transition through it. It could be used in atomic fires, and it could be used in airplane crashes and high-speed automobile crashes and trains, or whatever, whether it's diesel fuel or whether there's avgas or whatever kind of fuel fire. Now, we're going to test this same substance with magnesium. So we're going to test it against it. But see, we're not under such a great buoyancy wave or pressure wave of pressure to blow it out of your hand. So when I take that test, I take a big chance. It isn't you, the viewers out there, taking a chance. It's me.
You've gotten a huge response from Japan.
Yes.
3 million people watched it on a television show.
3.5 million in a week watched the same test, and they were part of the same audience who asked us to do this impingement test straight in the hand, like I just did. They asked for that, so there it is.
How can this product help Japanese?
They are having a real problem with radiation. Now, this material, if I put in another component, it becomes not only fireproof, extreme fireproof material for nuclear power plants, but it also it'll shade radiation to a high degree. Their ground is polluted. Their building parts are polluted with radiation. Their power plants had to be all taken down because they didn't meet specifications. They don't have a fire retardant that this is powerful. Neither do they have anything that'll that'll shade radiation, so they basically weren't prepared. So this could prepare any nuclear power plant. Now this is made specifically for a plasma plant, in which I intend to build a plasma plant.